Alright, looks like I am more than well live. So just gonna kind of hang out Friday night here and do some game engine development on my Cold Steel engine, which is not at all really an engine. I took out my stars now. So yesterday, not that you could see, I implemented some what is it? Separated axis theorem collision detection. The collision detection actually is very good, but the collision response is just terrible. So I think I'm gonna rip out. Well, actually it's correct, because what's happening is it's kind of like they're touching and then they kind of push at each other. I don't know. But I thought what I would do is rip out any real collision response. And then implement maybe broad phase and then narrow phase collision detection steps, or whatever you would call it. And then go from there. So just kind of playing around, I guess, as is with all things. So in my world here, here's where my collision detection's happening. And then minimum, okay. And I gotta remember where I'm at. So then I just offset the first collider's position by a little bit. So what I want to do is to switch this to do some broad phase collision and then some narrow phase collision. And I'm not sure I fully understand how that works. I've done just a little research to know what it is, I think, but I haven't done any implementation research, which is going to be kind of interesting. So what I'm going to do is implement it the way I think it might be implemented, and then go from there. So how I think it might be implemented is basically let me just bring up like Paint or something here. Oh, not Paint.net. Well, Paint.net, that's fine. Oh, shoot. No, I didn't mean to do that. Oh, okay. So what I think it is you've got a screen like this, and basically what you do is you split it up into segments like this, and then so this is like a box itself. Think of it as like a giant collider. And this is like a giant collider. And this is like a giant collider, right? So what you do is you set up these regions that are just really big colliders. And then you've got, sprites intermingled in between them. Well, yeah, let's say that's there and there and there, and yeah. So you set up these giant collision segments, and what you do is you go through every sprite that might be in the scene, and you say, okay, what intersects with this giant collision section? Well, that giant collision section would be this red box right here. You think Control-Z would work? Edit, undo. Well, it says it would do it. Whatever. So it's that one, and these ones. Oops. Yeah, Control-Z is just not working. And that one and that one. So that would go into this one, and then you've got this one down here with these, and this one over here with all of these, and then this one here. So you basically, what you do is you find out what's in there, and then you can further say, okay, well, anything in this region obviously is not going to collide with anything in this region, and so on and so forth. So then you only focus on collisions among this smaller group. So what it does is it narrows the amount of collisions. Now, if all of your boxes happen to be in one little quadrant, well, you're kind of SOL, I guess. You're not going to gain much out of it. But if they are properly in, some sort of a region, then you could probably get a fairly good gain out of it. So you do this broad phase, and then you go into little details and say anything within these regions now compare them. So you're basically splitting them out into chunks and then, you know, actually doing the collision detection. So so yeah, that's what I think needs to happen. Now, how to make that happen is kind of probably going to be a little interesting. So this collide as is takes a list of colliders and then the game time for whatever reason. But what I could do is create a second like narrow collide where it's basically this, but it just takes the exact same thing, but it's post your broad phase collision, which really is what I need. So let's just do that. Okay, so everything in here, what I'm going to do is do broad phase, which will give me a list of colliders for each of those segments, and then for each so do the narrow collisions. Okay, and so what I think that will do is I think it will give me an optimized thing. Now I don't know. This is just tinkering around, so who even knows, right? Now the one thing that I also have to decide on, whoa, that was weird. Okay, oh, paint, whatever's done, is whether I want to do any sort of clipping, which I think is called clipping. So basically, like, imagine that this is your overall world size, and this is what you see. How far outside of what you see do I want to make these, quadrants that can do collision? How big do I want to go? Like forever? Do I want to just do like what's in the box plus some, that kind of thing? What I think I could do is say that you have to define world bounds to be some particular size. Now, it won't enforce that things have to be within the bounds, but the world side bounds would be basically the maximum size of your quadrant, which is completely irrelevant to the size of the view. So your viewport, let's say, is here. Here's your origin center, and then just your bounds kind of go around that, I think is what I would do. Yeah, so I think that's what I will have to do. So take my viewport that I have, or my window, take the world and say, okay, how big are you? Shift that world to, or the bounds to the viewport center, and then do the this feels like it's going to be quite complicated. Maybe. I don't know. Maybe I'm thinking too broad at this point. Maybe what I should just do is take what's on the screen. Of course, I don't have like a stage thing that I can attach to and say, okay, what's your size? And then go and do that. That's quite a pickle. Maybe I don't even want to do that right now. Maybe I just want to get this back into a, it's one thing I haven't done yet, and I got to re-speed up these bullets is wait a minute. That should have, oh yeah, that's right. I took out the collision detection. what derp fender should do is when those things collide is blow up. Well, there's no actual callback into behaviors, so maybe I should start by doing that first. So right now what I'm just going to do is say that every single thing. Another thing I could do, actually come to think of it, is figure out how far all colliders are from each other and use that as the bounds. Which I could do here because I'm identifying all colliders. So what I could do is say, give me, is the x position of this collider lower than, or the rightmost of this collider lower than, are any verts on this lower than the minimum current lower, and then is, anything higher, and then that will define my large box, and then I could just split that down the middle and across and go with that route. That would be totally doable, actually. But I wouldn't need to do it here, so necessarily, although that would save me an extra loop, because I wouldn't have to go through all... Well, no, these are purely just the colliders, so going through a loop. Maybe that will be another optimization later. I have a lot of optimizing to do with this, actually. There's so much crap that I've just thrown in there. So what I mean is, okay, so for our collider in colliders, so each collider has a set of verts. Or vertices. Collider dot vertices. And what I'm saying is, so var min x. Actually, I shouldn't put that as min. What I need to do is get the first vert. So if colliders, if there's not any, there's no collision to do, colliders dot vertices. This beer is kind of getting to my head apparently. Okay, so first collider, vert and vertices. What I need to do is say ooh, this is actually tricky. What I should actually do is collect all vertices and then just go through them one by one, starting with the first, not first colliders. So verts equals colliders dot select many c dot verts. First vert equals verts dot first, and then go var min x equals first vert dot x, var max x equals, actually now vector 2 mins equals var vector 2 max equals first vert. Okay. So presumably one dot, the min and the max are the same point, obviously. So for each var vert inverts, if vert dot x, actually what I should do is just go mins dot x equals math dot min vert dot x mins dot x. And just do that for y's. Does anybody know what the hell a dot product is? I just do not understand that at all. I need to really go through and understand what a dot product is. I kind of get how to calculate it. It's really not that complicated. It's just x of, you know, vector 1 plus times x of vector 2 is the products of the, you know, whatever components. So x of v1 times x of v2 plus y of v1 plus times y of v2. But I don't understand what it's actually calculating, and it bothers the heck out of me. Maxes. Okay. And these should be maxes. All right. So when this is all done, I will have a minimum and a maximum, depending on which way you're actually viewing my screen. And so that defines a rectangle for which I can actually then, okay, take the distance between the two, the min and the max x, divide by 2, that's my center point here, and then my y's center point. Those create 4 particular rectangles that then I can break down into another segment and go on and so forth and so forth and so on. Okay. And then what I have to do is say, okay, do these collide with these broader rectangles? So I need to essentially define some box colliders, or some colliders for them. And then do, okay, this shouldn't be a big problem. So let's break that down into, you know, quadrants or whatever. So I've got my min and max size. So what I could do is do some sort of recursive thing where I break it down. So broad colliders equals new, actually no, get broad colliders for mins, maxes, and then levels remaining, let's say. So let's say we want to go 1, 2 levels deep. Let's just go with that for a recursive algorithm. All right. Mins would be your upper left. Maxes would be your lower right. And V would be your levels. Okay. If levels equals 0, and then what I need to do is actually add I'm not really sure. We'll come back to that. So levels is just to know when to return. So how do I know if I've broken things up well enough? Actually, no. What I want to do here is return new box collider with dimensions of your low r dot x minus your up L dot x with your low. Ooh, wait a minute. This is actually positions when I create a box collider. or rather around some center point, what I want to do is take that. Can't use a box collider here, a normal box collider. Crap. What am I going to do? Define an abstraction that's not a box collider. Well, really, all that gets used here is these vertices and edges, which I could abstract out into something else called a polygon. Let's do that. Polygon. Okay. Public class polygon. And a polygon will have public. And let's make this a struct because we don't really want to be creating an object all over the place. We want it to have vertices and edges. So polygon's an internal thing with vertices. Well, that can be the same. And edges. Okay. Then a box collider has a polygon. Shape with a get and set, and the set will be private, which then, if we get rid of translated and edges, assume that that's on the other thing, what it'll be is shape dot translated vertices and shape dot edges. Let's make it a class. Screw it. No sense in prematurely optimizing, which I'm doing by the very nature of doing this right here. Okay, and then shape.vertices, shape.verts. Wait a minute. Oh yeah. And I don't know why this has happened to me, but Visual Studio has stopped registering stuff in my error list window. I am not sure why. Okay, so this looks to be the only issue. So what I can do now is say return new polygon, setting its new var width equals low r minus dot x minus up L dot x var height equals low r dot x minus up L dot y. Oops. Sorry, up L dot y. So that gives me my height and my width. So what I can do now is say var polygon pg equals new polygon. All right, right, so its vertices are equal to new array of vectors new vector 2. So actually, first it starts with the upper L left, then new vector 2 should be your up L dot x, no, dot y, actually it would be your lower right dot x. Let me just fix this quick. Up L dot x, and your upper left dot y. Then it would go down to your lower right, then it would go to new vector 2 upper left x, and your lower right, or your lower right's y. So that would go boom, boom, boom. Then I think I need one, no, this is good. Okay, then I need to make my edges, which is not so tricky. So basically what your edges are vectors from one position to another. So let's just fix this here and call this, we don't need width and height. What this is your upper right. And what this is upper right and your lower left. So those are those. So upper left to upper right to lower right to lower left. Okay, so then your edges are from your upper right minus your upper left. So it goes from your upper left to your upper right. So the vector is from that to that, so you have to subtract them, right? Then it's from your upper right to your lower right. Then from your lower right to your lower left. Then from your lower left to your upper left. So those are your 4 edges. All right. And then you add that to your list of polygons. And we'll call them var, no, we're just returning that. PG. So this will return, ultimately I need to return a list of polygons. So what I want to return into here is an IEnumerable of polygon. Okay. I should have actually blown up down here. Why didn't I? Oh. Ooh, because those were inherited from this, which is fine, because what I could do here then is go box collider shape edges shape dot vertices. Okay, perfect. return a polygon. What I need to return it is a polygon with one item in it. How do you do just an enumerable of one? Well, I could just create an array, which would give it to me. Okay, then I'll need a concat going up. Okay, so if the level is equal to 1, I create a polygon and return. Otherwise, what I need to do is split the current polygon that I have into 4 quadrants. Okay. So how do I do that? What I do is say actually, well, no, I can't return it. What I need to do is say create my list, concatenate on a bunch, and then return. So if I go like, I'm going to need polygons equals enumerable create an empty enumeral of type polygon. Okay. Then I will do polygons dot concat which returns polygons. Polygons dot concat on get broad colliders for the first quadrant, and then levels -1, which your first quadrant is your upper left to half the distance to your lower right, which should just be your lower right divided by 2. Why not? Right. Okay, that should give me the first quadrant. And the second one is your new vector 2 is your upper left dot x. Whoa, Steam just randomly decided to fire up. I don't know why. Oh, Steam hardware sale, holy cow. So, anyways, actually, I don't know if this would be correct to say divided by 2. Maybe I do need height and width here. Or half width to half height, really. So far, half width equals your lower right x minus your upper left x divided by 2. And your half height equals your lower right's y minus your upper left's y divided by 2f. Okay. So then this one goes from your upper left to your new upper left dot x plus half width to your upper left dot x y plus half height. Okay, then your second level here goes to from your upper left dot x plus half width, and your upper left dot y plus half height to your new vector 2 which would be your upper left dot x plus your just width, which I'm doing. Then it's your upper left dot y plus your half height. No. Sorry, it's your half width. No. It's your half width to full width. And then your half height. It's actually not your half height here. No, this one goes to half height. This one is not half height. This one is half height. So shift translate your x, then translate your, okay, x and y. All right. So I do need to calculate w. Bar w equals this, and var h equals this. Oops. Okay. Back to it here then. So it really doesn't matter which order I do these in, so get broad colliders. Let's clear this up. Give this a little bit less depth on our screen here. All right, so you've got your upper left to your upper left plus half and half. You've got your upper left plus half to your upper left plus full, your upper y to your upper y. Okay, so now we can go the exact same y, no, not y position, x positions, but then, so ul dot new vector 2, which would be your ul dot x, straight up, to your, and let's, just for the sake of it, for making this kind of more uniform, let's just say this is uniform x's to your, and your ul dot y. So this is your upper left's x and your y plus half height to your dot x plus half width and your plus full height and then one more to go. Which would be your x plus half width and y plus half height to your x. And really this is just your lower right here. Which I forgot I could use. So I don't actually need full width and height because I can just use L. So why use that? I say. What am I doing? That's right. La, la, la. So when this breaks, we go, your x plus your full width is actually your lower right's x. And your lower right is your full height is your lower height's y. Why do I feel like there should be one more? Upper left xy to upper left plus half, then upper left plus half width y to lower x half width, okay? Then upper left's x with half height to upper lower right y, upper half to lower, no, that's right. Okay, so this should give us, and then if we just return polygons here, this should give us all of our broad colliders. Okay, so then what we need to do is go through each broad collider and check to see how many, smaller list. So go through the larger list and then check to see, and then break them up into lists based on their colliders. Oh, this is gonna be tricky. Not tricky, just kind of slow. The question is, do we go one by one? Okay, so if we have 100 items, we're gonna have tons of items, let's say thousands of items. Going through them once and then going through each sublist would be better than going through the list over and over again. So what would be best to do here is to go for each bar collider in colliders. Whoops, this should have game time on it. But, well, that will happen. For each collider in colliders, not go through each one necessarily. Well, yeah. So what I need to do is for each of these broad colliders, not really broad colliders, but broad regions, I need to create like some sort of structure to just throw them in quick. Just for the sake of doing this, I'll create a struct with broad region, I'll call it. Sorry, this should be just a polygon. And we don't really need that. Let's just put shape. Public list of, and this is where we want our colliders. Okay. So instead of returning polygon here, we're going to turn our broad regions, which then will contain a new broad region with shape equaling pj. And it's intersecting. Just a new list. I don't know if I have to new one up here. Okay. Why does that not like it? Ooh, dirt. Okay. So when we do here, it's not an empty of polygon, it's broad region. BR broad regions. Okay. Perfect. And then we'll go through, and for each collider in colliders, if collider, no. Another tricky thing which I hadn't accounted for is that I handle these collisions based on check collision. If I make this a polygon, what happens? P1, P2, hopefully it should just, everything should just sort of work. Other than this, which needs to be polygon. P. Oh yeah, the positioning. So what am I going to do about that? Oh, I can just do this after the fact. Where I was calling check collision before, I will do it right here. P1, which is C1. And the axis is now the result dot minimum translation vector. No, not your minimum. I'll have to calculate that outside too. Which means I can't return minimum translation vector. I have to return my axis and my length, which is your min interval axis. Won't worry about that there. Okay, so I moved all that stuff out. So now I should just have check collision between two polygons and be done with it. That don't have any position, all they have is, which I should have just added position to them. Whatever. Derp. But I don't really need to do that processing otherwise, so for each collider, if collider, if check collision between a collider dot shape, which should have a this is going to get all screwed up when I switch over to having some circles, but whatever. I'll figure that out when the time comes. So polygons are all we've got right now. Check collision between the for each var Now I really shouldn't necessarily have to look this up every flipping time. What I should do is keep track of ones that have moved and then go and say, okay, well, if you've moved since the last frame, then update your region. Although your regions might change based on the way I've done it, so good point. So check collision between the collider shape and the broad regions shape. If result colliders intersect, then what I will do is the broad region that I have dot intersects add a collider. Okay. The alarm going off outside my house. Anyways, finally, what I'll do is go through each region again and do the perform the narrow collisions on it. I don't think this actually needs game time, but this should really be more like intersecting colliders. Okay. Let's see how this feels. There's a hole that's waiting for you in the dark. You don't have to change a thing. The world can change. Ooh, oh yeah, I added a shape. And one failed. Cannot from physics collider to polygon. Check collision between C2.shape. C1.shape. And 2 succeeded. Perfect. And what did I do wrong? No scars for your beautiful vertices dot length. The shape is undefined. So this should go in the base constructor. All right, let's try this again. Stack Overflow. What? If levels are 0, then return. All the levels are... Oh. And this shall be less than or equal to 0, just to make sure. See how many of these I can flow before it starts to get slow. You know, so far so good. There's a house waiting for you in the dark. Yeah, this is performing like a heck of a lot better than I was before with this many items on the screen. And it seems like collision is properly working. Yeah, so this is actually, so nothing out here is colliding, going through all of these like this should eventually start to, no it won't, because this actually, these things delete on either side here. So this is pretty decent on the speed side of the world. So I'm actually pretty happy with how the broad phase stuff kind of worked out. Now there's, again, optimizations you can do upon that, but that's pretty not so terrible. Not so terrible indeed. I need to speed this up a little bit. Oh no, this is spawn enemy. I didn't think they were moving that bad. Let's change that to 1. Let's go ship and change this to... Okay, there's currently no bounce because I can't freaking figure that stuff out. Let's just change that to 1. So all of those collisions, what it should do is these things should turn into debris, and the bullet and stuff should kill itself. But I haven't actually registered or told the thing to say, hey, a collision's occurred, so blow yourself up. So some of this stuff, like the bullets stop for a second and you wouldn't see the thing, but the intersection does actually happen. So alright, well, I think that's going to be it for tonight. So that was some really poorly done but fun to do broad phase to narrow phase collision detection. Alright, have a good night.